In this video, we're going to do some exam style questions on logarithms. In the first question, part A says, given that y is equal to log to the base 8 of x, find expressions in terms of y for 1. Log to the base 8 of x squared and 2. Log to the base 2 of x. So let's start with the first one and use the power law. So all we're going to do is bring that 2 down, so we can write this as 2 lots of log to the base 8 of x. We know that y is equal to log to the base 8 of x, so we can simply write this as 2y. So that's our expression. If we now look at the second one, we've got a couple of different choices with this. What I could do is write this in exponential form. I could write this as 8 to the power of y is equal to x. I could write that 8 is 2 cubed to the power of y, and that's going to give me x. I could write this as 2 to the power of 3y is equal to x, and substitute that in. So now I have log to the base 2 of 2 to the power of 3y. This is just going to give me 3y. I can show that by bringing the power down, and we know that log to the base 2 of 2 is going to be equal to 1, so we end up with 3y. That's one approach. What we could have done is a change of base, and I'll do another example here. So what I can do is change a base, and I can switch this up now to base 8. So I can write this as log to the base 8 of x divided by log to the base 8 of 2. Log to the base 8 of 2 is 1/3. What power is 8 raised by to get 2? The answer is 1/3. So we have log to the base 8 of x divided by 1/3. If we divide by 1/3, we're multiplying by 3, so we have 3 lots of log to the base 8 of x. We know that this is y, so we have 3y. So all we've done is gone ahead and done this 2 different ways. It's entirely up to you. In part B, it says, hence, otherwise, find the value of x such that 3 lots of log to the base 8 of x squared plus log to the base 2 of x is equal to 6. So let's make our substitutions. We know that we've got an expression in terms of y for log to the base 8 of x squared. So I'm going to have 3 lots of 2y. Plus now my expression for log to the base 2 of x, which is going to be 3y. And that will be equal to 6. We're solving for x. Currently I've got my equation in terms of y. I can divide both sides here by 3. So I'd have 2y plus y is equal to 2. So I'd have 3y is equal to 2 and y is equal to 2 over 3. Therefore, now I just need to substitute this back in and say that 2 over 3, so 2 over 3 is equal to log to the base 8 of x. So rewriting the exponential equivalent, we can say 8 to the power of 2 over 3 is equal to x. We take the cube root, which is going to give me 2, and we square. So we can see now that x is equal to 4. And in the exam, go ahead and check, and you'll see that that will hold true. So all we've done is rewritten this now and used the log laws and now the exponential equivalent. It's your choice at this point how you want to approach this part. Okay, let's go ahead and look at another one. We're asked to solve the simultaneous equations. Log to the base 2 of y is equal to log to the base 2 of the quantity 3 minus 2x plus 1. And log to the base 4 of x plus log to the base 4 of y is equal to 1/2. What I'm going to do here is subtract the quantity log to the base 2 of 3 minus 2x from both sides. So we'll call this one equation 1, let's call that one equation 1, and this one equation 2. There are a couple of different approaches that you could take. So my first move now is to write this as log to the base 2 of y minus log to the base 2 of the quantity 3 minus 2x, and that will be equal to 1. And this is equation 1. I'm now going to use log laws. If I have the same base and a difference of logs, I can write this as a quotient. So I can write this now as log to the base 2 of y divided by the quantity 3 minus 2x, and that will be equal to 1. I can now write the exponential equivalent, and that is 2 to the power of 1 is equal to the quantity here. So we have now y over 3 minus 2x will be equal to 2. At this stage, I could express y in terms of x, and I could write y is equal to, multiplying both sides by the quantity 3 minus 2x, I could have 6 minus 4x. And that now gives me equation 1 as y in terms of x. Let's go ahead and look at equation 2. I can now combine the logs. I've got now a sum, so I've got the same base, so this will become a product. Log to the base 4 of x multiplied by y will be equal to 1/2. At this stage, I can write the exponential equivalent, and that is 4 to the half power is equal to x multiplied by y. So we got 4 to the half. 4 to the half is equal to 2, so xy is going to be equal to 2. And that now is equation 2. I'm now going to substitute in equation 1 into equation 2 as I've got an expression for y in terms of x. So now we can write x multiplied by the quantity 6 minus 4x will be equal to 2. So all I've done is gone ahead and subbed that in. Now at this stage we could divide the equation by 2, or we can just expand it out and then do it. It's entirely up to you. So 6x minus 4x squared is equal to 2. So we would have now 0 is equal to 4x squared minus 6x plus 2. So dividing through by 2, we'd have 2x squared minus 3x, and then we'd have plus 1. So all we need to do is go ahead and factor that. So if we factor that, let's go ahead and do that. What are we going to have? 2x minus 1 and x minus 1. So 2x minus 1 multiplied by x minus 1. So we can see that x would be equal to 1/2, or x would be equal now to 1. We do need to check that these satisfy the equations. So if we consider now, I need to check that I'm not going to be taking the log of a negative number. So we'll go ahead and check those, and both of those are perfectly fine. All we need to do now is substitute into y is equal to 6 minus 4x. Or alternatively, you can sub it in just here. I'm going to put it into this one. So what we'll have now, we'll write when x is equal to 1/2, we will have y will be equal to 6 minus 4 lots of 1/2. So that's going to be 6 minus 2, and that's going to give me a total now of 4. So y is equal to 4. So we have now when x is equal to 1/2, so let's write this here, we can write x is equal to 1/2 and y is equal to 4. Let's now take when x is equal to 1. So when x is equal to 1, we can sub it into either of these. So we're going to have now y will be equal to 6 minus 4 lots of 1, and that will give me that y will be equal to 2. So we can say now that x would be equal to 1, y is equal to 2. So we have now the solutions. I always like to go back and check that we're not taking the log of a negative number, and we can clearly see that's the case for all of those values. Do check when you're finding your solutions, as some of them will not always be valid. So final answer, x is 1/2 when y is equal to 4, and x is 1 when y is equal to 2.